Hello, class. In this work, we're going to talk about the remainder theorem. But first, let's give ourselves a little bit of practice refreshing on our division. It says divide x to the fourth minus 5 by x minus 5. Give your answers in polynomial form and fraction form. I'm going to let you decide. I did not specify which method you must use. I'm going to go ahead and use synthetic division because that is a linear term we're dividing by. We do have some missing terms here. So we have 1 for the x to the fourth coefficient, and then 0 for the third degree, second degree, and first degree, and then the negative 5. All right. Drop my 1. 5 times 1 is 5. Add them together. We get 5 here. 5 times 5 is 25. So add those together, we get 25. 5 times 25 is 125. Add those together, we get 125. 5 times 125 is 625. Add those together, you get a remainder of 620. So polynomial form. That was x minus 5. And let's think this one through. We got x to the third plus 5x squared. Pardon me. Tripping over my words. Plus 25x plus 125. And then plus our remainder, which is 620. Let's go ahead and write in fraction form. So fraction form would just be our quotient, so that's x cubed plus 5x squared plus 25x plus 125 plus 620 divided by x minus 5. Okay, good. Now the question becomes, and this is where this lesson leads us, what if we didn't need the quotient? What if we just needed the remainder? So that's what this first question is asking you. Find the remainder of f of x is divided by each of these without using polynomial division. So we're not using synthetic, we're not using long division. Well, it's quite simple. We can relate it back to synthetic division. Think back to if we set it up, we would put a 2 in this space, okay? That would be if we're setting this equal to 0, we get x equals 2. Well, we can simply get the remainder by plugging in what we would usually plug in for synthetic division. So we do f of 2 equals 3 times 2 squared plus 7 times 2 minus 20. So we get 12 here plus 14 minus 20. We get 26 minus 20. If we went through synthetic division or long division, we would get a remainder of 6. Let's try it again. So this time we are doing f of negative 1. So 3 times negative 1 squared plus 7 times negative 1 minus 20. We get 3 out of here. Then we get plus a negative 7, so minus 7 minus 20. We get negative 4 minus 20 is negative 24. So our remainder, if we use synthetic division, would be negative 24. And then finally, we'll do it for negative 4. So f, I'll try and write this a little bit smaller. 3 times negative 4 squared plus 7 times negative 4 minus 20. 16 times 3 is 48. And then we do minus 28. Yikes. Minus 28 minus 20. So we get 20 out of here minus another 20. We get 0. So x plus 4 is actually a vector. There we go. So find the remainder when f of x equals same polynomial as before divided by x minus 2. So we're going to confirm it. It's not enough to just look at it. So let's go back. We had a remainder of 6. We're going to confirm that. And they're all linear terms, so we're just going to use synthetic division. We got 3, 7, negative 20. Okay. So we drop the 3. 2 times 3 is 6. Add to get 13. And then 2 times 3 is 26. Add to get 6. And would you look at that? Go back again, check it. And you get 6. All right. Try this again with negative 1. Okay, we got 3, 7, and negative 20 like before. We get 3, 1, or negative 1 times 3 is negative 3. We add them together, we get 4. 1 times 4 is negative 4. We get negative 24, and would you look at that? Go back, negative 24. So that means we should get 0 for the last one. Let's acknowledge that now. We do negative 4. We got 3, 7, negative 20. Drop the 3. Negative 4 times 3 is negative 12. We add these together, we get negative 5. 4 times negative 5 is a positive 20. And we get 0. Voila. So go ahead and give the exit a try. Determine if x plus 4 is a factor of this polynomial without using polynomial division. And don't just find the remainder. Make sure you give a sentence for why it is or it isn't. Thanks for watching.